Hi, my name's Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So, this is Hutchinson effect, magneto-toro-electrogravitic field interference-driven transmutation patterns on MFMP fracture sample. Whew, what a mouthful. Okay, we're going to be talking about this sample. This is a little piece of magic here, it really is. As I said, when I've presented this to people, they've not been able, who are metallurgists or people that know how to make things with metal, no one's been able to say how they could make this, and that's just looking at it on the macro scale. But when you see what I'm about to show you, you are going to be absolutely dumbfounded as to how this was engineered in anything other than something really, really special. Okay, so why have I said gravitic here? I've said gravitic here for a number of reasons. One is I'm kind of fed up with every time I'm talking about low-energy nuclear reactions and saying, it's a really interesting phenomena. People worried that I'm going to speak about anti-gravity, don't let me speak at a conference, or other people will say, you don't talk about gravity, it causes discredit to the community. And it's like, I haven't been talking about gravity, so what are you going on about? Anyway, it kind of makes you think there might be something to gravity being related to low-energy nuclear reactions and so forth. Anyway, so I've got a link here, and it's to a article or a series of disclosures from the interaction between Boyd Bushman and a claimant in Prague who claimed to have, decrypted some old Sanskrit and come up with some way to do anti-gravity. And so they were trying to arrange a meeting to go and check this guy's technology out. But actually, Boyd Bushman did describe something in one of his videos at one point where he took two very strong magnets like these ND52s. He put them on a brass bolt. This is actually stainless steel. And he pushed them together right the way so that, so if I go like this, you can see this is very strong. That's just pushing itself open. It's really strong. But basically, he held them together like so with a brass bolt and put the nut on the end here, so they were forced together, and then put the whole assembly in I think it was a metal sphere, but a sphere anyway, and then made another sphere of a similar weight, or the same weight, and then dropped it from, I think I recall it something like 40 feet, and had a load of students assess which one dropped at the same time arrived at the ground first or last or whatever. And apparently every single time, the one that had the two strong magnets bound together like this, they arrived later, and that breaks laws, doesn't it? Anyway, I have thought, was he dropping these by the side of a metal-sided building, and maybe it was delaying it that way. But anyway, that being said, that's gravity. And there's a nice segue to the image that I have over here on the right. And this is yet another image from a large tapestry that was I purchased in 2001. And this is from the northwestern desert tribes of India. And at this time, they didn't have any roads. They lived a nomadic life, and they had their own language, and they passed on their culture from their past times through their fabric work. And so I thought this was very appropriate to put this part of the tapestry on there at this point. Now, it's not just Boyd Bushman that's talking about this. We have the US Navy coming out under a person called Salvatore Pai, talking about superconductivity, high-frequency gravity wave generators, and effectively fusion technology, and basically saying all these patents are connected. Well, I want to talk about what Martin Fleischmann said, since this is the Martin Fleischmann Memorial Project, in 1996 in an interview in Infinite Energy magazine with Christopher P. Tinsley. And I will just read the whole segment here. I will say that some of this gravity modification stuff does, in fact, appear to have a theoretical basis, as well as some experimental evidence. And then Professor Fleischmann says, well, if you think about gravitation until we have a unified field theory, then you can't be sure what's going to happen. Tinsley asks, even Frank Close said that we don't know much about gravity and anything might happen. Mr. Fleischmann said, we really have an incomplete understanding. This will change, but there are one or two notable exceptions which I don't want to talk about now. We have no understanding of quantum gravity, and until that happens, we can't be sure that nature won't play some rather strange tricks. As I told you when we were talking before, we had about 4 projects which we were working towards. One of them was cold fusion. One was to do with gravitation. One was actually to do with the behavior of electrons in metals. We actually started to collect equipment together to investigate the behavior of electrons in metals. But, ... Now, in this entire 3-page interview, this is the only time where the Professor Fleischmann speaks, but there's nothing in between. It's like a little bit of the conversation is being cut out after this ... And then it goes on to say, I have told you there have been certain themes which have run through my work, although they have never really been disclosed. I have often worked on topics where something short of the final answer would nevertheless be quite interesting. So, you have the US Navy putting out this patent, or series of patents, which it says in the patents are all related. One is talking about high-frequency gravity wave generators. Another one is about superconductivity, and another one is talking about fusion. This does look like that Martin Fleischmann may have been working on a similar family of things. And might this explain that whenever I'm talking about certain subjects, someone pops up with a pseudonym hiding behind a non-real name, saying, "Don't talk about gravity; it will bring disrepute to the field." Okay, so anyway, let's leave that there, and I want to go on and talk about Alexander Shishkin here. And Shishkin made a wonderful presentation at Sochi in 2018, October 2018. I've just taken a couple of slides from that, but all the links, as always, will be in the description to this video, and this PDF with the links embedded into it will be there. That goes for the link to the interview here and to the Boyd Bushman article here. Okay, so it's joining a couple of things together. Firstly, he is saying that Charles Glover Barkla, the guy that won the Nobel Prize for discovering characteristic X-rays, and this is how we can tell what element is what element when we're analyzing a sample. At the same time, he found this thing that he called J radiation. He said it was J radiation because it was more powerful than KLNM radiations that come from the various shells of electrons in an atom. So J radiation, and in fact, in this same interview here, Martin Fleischmann talks about the fact that they've observed 130 keV plus photons, without referring to the fact that Charles Barkla had discovered this in the early 1910s. Anyway, Charles Barkla, he actually spent the rest of his life, 28 years, trying to work out what this J radiation is. Well, Alexander Shishkin is saying that J radiation is magnetotoroelectrical radiation. Okay, magnetotoroelectrical radiation. That's a torus that has high magnetic moment and it has electrons involved. And all I'm doing is I'm adding gravitic to that, because if the US Navy thinks it's good, if Martin Fleischmann thinks it's good, and as you'll see, there's other aspects that I will come on to after I've talked about Alexander Shishkin, I think it's fair game. Now, at the bottom here, Alexander Shishkin goes to expand the fact that essentially what he's calling magnetotoroelectrical radiation is a form of charge cluster, and he gives credit to Ken Shoulders for establishing the parameters of that and what happens when they break up. So he says, during an explosion of such a soliton, a significant part of the electrons acquire kinetic energy of up to 6 to 10 keV. Therefore, a characteristic mechanical damage of the film in the form of umbrella and or birdie appears at the site of the explosion. So he's referring to this thing, and these are X-rays. I'm going to talk about this and other up-and-coming presentations and my interpretation of what we are seeing here, but this is an extremely important finding. And quite separately, other than the team of Shishkin, who has been working on this for practically a decade now at Dubna, Science City in Russia, there is a group at the Moscow Physics University, Nuclear Physics University, under Bogdanovich. And he has also observed these birdies. So this is not a one-off occurrence. So there's a link to this particular presentation that shows the risk of the type of radiation that can come out from this technology. So the next person I want to talk about is Takaaki Matsumoto, and this person will tie all of these concepts together. Takaaki Matsumoto also observed these string vortex solitons. Here is one that's impacted on some radiographic emulsion. And I've got a link there, and you can go and see this article. Anyway, this guy was absolutely inspired, and I just want to focus the next part of the presentation on him and why what he found was very important. So first off, he previously researched options for treating high-level radioactive waste, and this was published March 1987. So if I go here, this is the article. As I say, the link that I give you here will be to the freely available Google scan of this. And so this is in 1987, and he's saying, nuclear incineration method is a method of converting the long-life radioactive nuclides in waste to short-life or stable nuclides. Now, you can read this in your own time, but essentially, Japan does not have its own hydrocarbon or nuclear sort of resources in the way that other countries do, and it can't chop down its forests because they hold its mountains together. And so they need a lot of energy. It's a large population in a small landmass. And so they went with nuclear. And this is interesting. Obviously, they suffered the attacks at the end of the Second World War. But they went with nuclear in a big way. And of course, then it's of great interest to them how to solve the problem of remediation of nuclear waste. So this was his position prior to the announcement of cold fusion by Martin Fleischmann and Stanley Pons. After starting experiments in 1989 into cold fusion, he had established by 1993 that gravity-driven collapse of nucleons and fusion was possible using electron-nucleon clusters. And I have his book here, and it says right there on the front cover, it's got a picture on the front and back, and it's just effectively a wrapped round picture here. And right here, you can see here, Miniban, gravity decay of quad neutron, discovered on August the 25th, 1990 in nuclear emulsion during cold fusion. You can't get clearer than connecting gravity to cold fusion than you see here. So perhaps this is why I get these anonymous people popping up and saying, you can't talk about gravity, it's going to bring disrepute. And this is all in Japanese, but I will say that you can get all these papers in fusion technology in English. And there's a couple of here that he's pointing out. So observations of quad neutrons and gravity decay during cold fusion. And then down here, observation of gravity decays of multiple neutron nuclei during cold fusion, so forth. So there we have it. And so expanding on that, I want to take you back here. So there's a note here. So in 1993, and I'm going to read these because I think they're very, very important. So this is in November 1993, and he's talking about comments to his experiment. He says, in Ref 1, Fox writes that strange traces that I observed during my experiments of one-point cold fusion correspond to electron beads, EVs, and that, unless he is mistaken, he congratulates me on the rediscovery of high-density charge clusters, or EVs. But I cannot be congratulated for two reasons. First, I observed things different from EVs since 1989. I have been proposing the NATO model, which predicts the production of new particles called itons during the hydrogen-catalyzed fusion reactions, which are primary during cold fusion, such as in Fleischmann-Pons type experiments. Itons, which consist of electrons, positrons, neutrinos, have a mesh structure and cover fusion products such as quad neutrons. Itons were introduced in 1990 to explain complicated spectrum of charged particles, and they can well explain the lack of neutron emission. Itons are completely different from charged clusters of electrons only, EVs. Furthermore, when cold fusion takes place, hydrogen clusters are formed, and they are covered by the itons. Thus, many hydrogen atoms are inside itons. It is impossible to judge whether such itonic hydrogen clusters are the same as the high-density charge clusters proposed by Shoulders, because he named his clusters but did not explain what they were. Fox asked me to write about EVs for Fusion Facts, but I had no information about EVs except an article from the newsletter, so I asked Fox to send me Shoulders' documents. Later, I received the documents from Ed Lewis. Second, Shoulders states in his patents that energy is extracted from the zero-point energy of the vacuum. If this is true, his discoveries are superior to mine. This is because, according to the NATO model, energy comes from hydrogen-catalyzed fusion reactions and gravity decay of neutron nuclei. Hydrogen is the fuel for the former, and hydrogen atoms the host metal, and the electrolytes are the fuels for the latter. Both phenomena consume resources of the Earth. On the other hand, zero-point energy comes from the vacuum. I observed the evaporation of tiny black holes during cold fusion experiments. They can realize the zero-point energy of the vacuum, but a black hole evaporates by absorbing particles with negative energy. This means that the energy actually comes from the mass of the black hole. This cannot be said to be a zero-point energy of the vacuum. Zero-point energy is better energy resource than gravitational energy. It cannot be denied yet that zero-point energy might be involved in cold fusion. I would like to search for that kind of energy during electrolysis experiments. If this is successful, I can be congratulated by Fox. Now, this is a typical sort of way of addressing things by Takaaki Matsumoto as a Japanese person, and self-deprecating and so on. But I note that the person that's looking at this is just calling this a denial. So, but essentially, exotic vacuum objects, electron validium at this point weren't very well defined at this point in 1993. Later he called them, exotic vacuum objects, because they actually have all of these different things that Takaaki Matsumoto is talking about in here. So maybe I moved the camera here. No, did I move this? I hope you saw that. Okay. Anyway, you can download this in your own time. Okay. And then I have a note here at the end here, because what happened is that between this being said and him trying to publish more articles in fusion technology, they changed the rules. And so actually Matsumoto in 94 wrote to Fusion Technology, and it was published in the December 1994 issue, in the typical polite way that a Japanese person would do when they're trying to get a point across. Two proposals concerning cold fusion, and I think this again is well worth reading right now. I would like to make two proposals concerning cold fusion. The first is related to the criteria in which cold fusion papers are submitted to Fusion Technology. It should be reviewed for publication. First, I would like to summarize some points about the history of cold fusion debate. Since the anomalous effects, now termed cold fusion, were first announced by Pons and Fleischmann and Jones, many experiments to prove or disprove the effects have been carried out. However, there were very few scientific journals that would accept papers on the topic of cold fusion. Under these circumstances, the courageous policy of George Miley, editor of Fusion Technology, of allowing such papers to be reviewed for possible inclusion in Fusion Technology was significant. His policy should be highly regarded in the history of this new field. And essentially he argues here that there was nothing to compare anything against, so how could you come up with any peer review? And often actually in the early papers of Takaaki Matsumoto he would refer to himself, because he was the only person that was actually bothering to look at these phenomena that he was seeing. Now down here he says, at the Maui Cold Fusion Conference I presented the observation of tiny ball lightning phenomena in some cold fusion experiments. In nature, ball lightning seems to occur frequently, although I have never personally observed this phenomena. One attendee at the Maui conference told me that he had seen it in his youth. Extraordinary phenomena associated with ball lightning have not been fully understood, since in my view, some type of cold fusion is involved in the production of tiny ball lightning. It is not surprising that this extraordinary phenomena has not been explained by conventional theories. We should be ready to confront such confusion. If we continue to reject frank discussions and proposed theories without testing or trying to improve them, we will never be able to fully understand or explain the mechanism known as cold fusion. The first proposal that I would like to make is a return to the initial criteria for publication in fusion technology of extraordinary phenomena related to cold fusion. Of course, the conventional measurements such as heat, neutron emission, and production of tritium and helium now have extensive experimental database and should undergo the normal rigorous review. However, other aspects, ball lightning being an example, are still in the very preliminary stages of investigation. I believe that in the interest of allowing dissemination of new results, the earlier criteria for evaluating these papers should once again be used, and these papers should be published as technical notes on cold fusion. Thus, I propose that FT fusion technology utilize these dual criteria until all aspects of cold fusion are cleared up. What he's basically saying here is, I'm trying to submit to you papers and under the same basis that you allowed them to be published in the past. But now you're finding neutrons and tritium and helium. You're only allowing papers that have found these things or excess heat, whereas I'm finding all kinds of other things during my cold fusion experiments, and you're not allowing the papers to be published. And in fact, you can't find papers after this period published, if I'm right in saying this, and I would like someone to try and find if there were. I think it was after 1904 or 95, there was no more papers of Takaaki Matsumoto published in fusion technology. And this is interesting because this is about the time that he really starts talking about ball lightning and also gravity decays and really pushing those concepts. So this is concerning. The other thing is he's proposing here at the end there, which is beautiful. He would have been perfect in the MFMP. I really like his phenomenological approach to LENR. And he's saying that, it would be really nice if other people paid attention to what was going on in terms of the strike marks and things that you find in nuclear emulsions. And he's saying that this may be because nuclear emulsion techniques are unfamiliar to chemists and fusion scientists, although they are popular with nuclear physicists. So he's basically saying, look, if you do what I'm doing, you're going to find these things. Please, let's join together and try and categorize these things. And I think this is almost a desperate plea because, everyone's found these heat, neutron emission, and so they're allowing these papers to be published. If he's the only person out there finding all of these other things, then there's no other peers, is there? So, he needs some peers to be able to be back in the publishing game in fusion technology. So I think that's really important to note at this point. Then, in April 2001, he actually presented at the OECD Nuclear Energy Authority on how the process behind LENR could be used for advanced nuclear reactors which relied on the process wholly or in part. So I don't actually have the whole paper here. So it's actually here. So I don't have the paper, but I have the abstract, and you can. The link that I give you will be to the OECD's NEA website where this is there. And again, it is worth reading this because it's so significant. Basically, for nearly 20 years, the International Nuclear Authority has been aware, or should have been aware, of the possibility of at least Takaaki Matsumoto's interpretation of low-energy nuclear reactions. So advanced reactors with application of electronuclear reactions. Recently, a special state of atomic cluster called atomic cluster or micro ball lightning was discovered during experiments of electrolysis or underwater spark discharges. A new kind of nuclear reaction called electronuclear reactions, ENRs, including nuclear collapse, electronuclear collapse, could occur in the clusters. Since ENRs emitted few hazardous radiations, such as energetic neutrons or gamma rays, ENRs occurred very safely. Furthermore, it was suggested that ENC, electron nuclear collapse, could be induced by fission reactions products with a high irradiation dose of neutrons. Those properties of ENRs were potential to make conventional fission reactors significantly safer, as well as to build an innovative electronuclear reactors. Here two proposals will be made as applications of ENRs to nuclear systems. The following subjects will be described. Principles of ENR will be summarized by showing evidence obtained during USD experiments. An innovative light water reactor will be proposed, which could hold a low in-core inventory of radioactive materials. Here, electronuclear reactions induced by fission products could be applied. And then an innovative electronuclear reaction will be proposed in which electronuclear collapse, it's about like kind of fusion, isn't it? But it's actually a lot of things at the same time, could be directly employed for energy production. And so he actually handed out books to the people at the Nuclear Energy Authority and so forth. Anyway, the last one that I want to draw attention to is in a letter to Fusion Science and Technology. In this, he conceded that the process he had researched was essentially that of Ken Shoulder's EVOs. So remember, in 1993, he denied it was the same, but there was less information from both parties. And then he additionally said that he understood it to be a many nucleon effect, not just a few neutrons. So I actually have that here, and so I will read the sections of that which are key. So he's responding to Ed Lewis. Evidence of micrometer, he's commenting on this article, evidence of micrometer-sized plasmoid emission during electrolysis and cold fusion. Recently, we have observed an increasing number of researchers who began to recognize the important role of small-sized charged clusters. I'm gonna zoom into this, it's easier for you to read. That could be generated during cold fusion CF-related experiments. The curious clusters were a key point to understanding various extraordinary phenomena observed during the experiments: an excess heat production, nuclear transmutation, and ball lightning-like phenomena. New kinds of nuclear reaction could take place within charged clusters. As Ed Lewis described in his letter, 3 models were proposed for the curious charged clusters so far. Plasmoids by Lewis, and plasmoids is a name that was given by researchers Nardi and Bostic initially in the 1950s that I talked about in the previous presentation. Electron beads by Kenneth Shoulders et al. And itonic clusters by Takaki Matsumoto. Lewis pointed out the similarity between plasmoids observed in plasma-focused discharge experiments by Nardi et al. And traces that were obtained from nuclear emulsions during my electrolysis cold fusion experiment. I appreciate him for having carefully watched my data. Shoulders et al. Proposed a model of electron beads by performing a discharge experiment. I proposed a model of special clusters, the NATO model, as soon as cold fusion was published, and developed it by performing experiments of electrolysis and underwater spark discharges. Probably, we discussed similar objects with different terms having different contents. According to the NATO model, a special state of clusters called itonic clusters could be effectively generated mainly on the surface of atomic clusters. So itonic clusters on the surface of atomic clusters when many electrons were charged. Here, many electrons were assumed to be interconnected. Bonding of those electrons could be so strong that the clusters were violently compressed. Several kinds of nuclear reaction could take place within the itonic clusters. The most significant reactions was nuclear collapse. So this is packing things into a very small box, which induced an explosion, and during which mesh-like networks of interconnected electrons could be broken up. My 3-ring traces were products of those simultaneous explosions. Here I have to apologize to readers for an insufficient assignment made in Ref 5 that quad neutrons collapsed. It was made clear by later experiments that clusters that collapsed were atomic clusters that could have a diameter of hundreds of micrometers, and involved much more nuclei. We are observing this across a wide range of experimental data from independent authors. Very amazingly, it was also found later that the ring products consisted of conventional elements, mainly carbon, not dependent on collapsed materials. This is very, very important. Look at all the carbon we observed when we were testing with Amasa gas. And I will tell you right now that when Yul Brown was testing his Brown's gas remediation of cobalt-60 and americium-241, the main product, and it is cited in his patent, I believe, the main product that comes out is carbon. All of these data points are lining up. I will show you many places where clearly an EVO is struck on, say, the 10 yen coin, and there is a carbon deposit when there's no carbon in the coin in that kind of level of concentration, and there's no carbon in the flame. This process was called nuclear regeneration. Furthermore, white wispy markings between my ring traces were remains of interconnected electrons, which were more obviously shown in Figure 3, Ref 6. Those electrons formed network-like mesh and played an important role in causing curious phenomena like ball lightning during cold fusion experiments. And this is very, very, very interesting, this last bit. I would agree with Lewis's idea that the ring craters and markings like brush discharges obtained by Nardi et al. Resembled well the ring products and white wispy markings during my cold fusion experiments respectively. But it would be much more important for science not only to observe surfacial phenomena, but also to understand the physics involved there. An element analysis would easily resolve the problem. If nuclear collapse were involved in the experiment of Nardi et al., a large quantity of a carbon element should have been found in the ring craters. You will see this. I will present this. This is in the Mars gas treated coin and other samples. Lastly, I would like to point out that atomic clusters were different from plasmoids. First, the model of plasmoids could not explain the feasibility of nuclear reactions, especially nuclear collapse, because of their weak bonding force. Second, atonic clusters could be generated not only in a plasma, but also in other wide fields, for example, during high-pressure compression or thermal heating. Other orbital electrons of atoms involved in materials could easily be interconnected. I will publish many beautiful pictures elsewhere that show mesh-like structures of interconnected electrons formed in the natural phenomena. And you will see the mesh-like structures that I shared from the Amasa vibrator plates. This is the same phenomenon. Okay, so I think that just to close out here, Ken Shoulders had established in 1980s that exotic vacuum objects were the cause of John Hutchinson's effect, i.e. what is going on here is caused by exotic vacuum objects. In 2001, Takaki Matsumoto said that cold fusion is done by things which are EVOs. Effectively, he admitted that. And he does invoke gravity collapse as well, but he says it's not just a group of neutrons, it's actually, as he said, and records on the front of this, it's actually hundreds of microns of atoms simultaneously. That's a lot of material that's being collapsed. And the output is generally carbon, just what we observed in Roy Shinamasa's test, and also what is claimed by Yul Brown. And then at the bottom here, it is already shown by us how Hutchinson effect is related to the US fusion program post-World War II via Bostic, and to replicate solar energy sources, and how it is also related to Nikola Tesla's work. Obviously, because John Hutchinson was using Tesla's drawings to develop things, and that's how he came about by his effect. Okay, so the next one is this. This is absolutely breathtaking. You are looking at a section on here of the fracture sample, and you can see this very large, sort of undulating, almost looks like a quilted pillow. And it isn't just the shape that you're seeing here, which is stunning, it's what's going on under the hood. Okay, so I'm going to take you this. Now, all of these, the raw SEM element maps I will provide to you. But essentially, we have these raised areas, this 90 degrees orthogonal kind of structure, wave structure, which is, quite a lot of displacement going on, and then these pits and these holes. There's another one over here which you can't see. You can see on the overall image. There's a big hole up here, and there's a flat bit here and a flat bit here and this curved bit here. Now, where it gets really, really bizarre is in the last part that I'm just about to show you. Here, you can see these dimples all over here. Well, the dimples are actually different elements to the aluminium that it started out as, aluminum for you American chaps. And I must thank again also Alan Goldwater for putting his money on the line to purchase a scanning electron microscope with EDS and in his Magic Sound lab. That's how we got these images last year. Okay, so if you take the material here, you have aluminium, and aluminium can go to magnesium and silicon. You've got two fermionic isotopes, which obviously it's fermionic, it's aluminium, the nuclei, and that is going to bosonic magnesium and bosonic silicon. And I'm just going to play this because it's absolutely stunning what you can see here. Because there's the aluminium is the kind of this color, the aqua color, and then you've got the magnesium is dark blue and the silicon is this purple. But look at this over here. You have in these two spots here by the holes, one with a flat line pointing this way and one with a flat line pointing that way. So mirror and orthogonal. You have something that has no aluminium, has silicon, no magnesium. Anyway, it's absolutely beautiful. You can look at this in your own time. As I say, I will share these images. Now, the next one I'm going to show you here is a close-up. And when you look at this, you can see that you have a ring with a spot in it on the magnesium. And the silicon, which is the heavier of the two elements, is centered. So here you've got a large block of the magnesium, and you've got a centering of the silicon. So the heavier element, i.e. the better, closer packing density element, is in the center of the spot, and on the outside of the spot you have the lighter element. So it's like it's packaged a whole load of aluminium into this vortex, and the bits on the outside have had to be lighter, and the bits on the center are heavier, and they're all bosonic so they can occupy the same space-time. What you are looking at here is absolutely breathtaking. It's just breathtaking. Okay, so the next one I want to show you here is silicon and calcium and iron. And this is so striking. It's so striking. On this side and on this side, these two orthogonal but mirrored structures over a hole, you have calcium and silicon. Calcium and silicon. Okay? Now on this side, you have iron and silicon, but no calcium. Silicon, iron. Silicon, iron. But here, you have silicon and calcium, but no iron. So this side has silicon and calcium, but no iron, and this side has iron. There is literally no way that you could find any... I would like someone to tell me how you could make this what definitely looks like some sort of field interference technology in any other way than with a Hutchinson effect. This is, as I said at the beginning of this video, a little piece of magic. And here you can see in the Parkhomov fusion reaction tables, if you take magnesium and silicon, you make iron isotopes. So it's kind of synthesizing the magnesium and the silicon from the aluminium, and then it's doing something down here. You can investigate the Parkhomov fusion tables, and over here I've got the exchange reactions. These are exchange reactions. There are other options to get to this. And the last thing I want to show you is this, where you have this kind of self-organization going on. So what I've done here, these are 5 micron and 10 micron circles. And you can see, firstly, there's almost a line here. There's almost a line. And there seems to be some sort of separation. They don't like to get too close together. It's like they're like. It likes coming together, but then it starts to repel when it gets too close. But there definitely seems to be a line here. And actually on this line, you will see that there is these other elements stuck to the surface. So this line is running along here, and there are these large elements, and these tend to be carbon. And then at this point on the top, on the crest, this is titanium. It's absolutely crazy. It's so amazing. This you can read into it and explore it. Like I say, the SEMs and the element maps will be shared. Okay, so then I'll just show you this one. So this is self-organization, and this one I kind of want to show the concept of field interference here.
So there does appear to be some lines of dots, but if you look at the lower set, the magnesium is sometimes not alternately not there or less there, and there's no silicon. So it looks like the compression at that point has been less, or it's some constructive or destructive interference.
I would encourage you to have a look at these images of this part of the Hutchinson fracture sample and see what you can see. I will be showing you more details of other areas of this sample, and I can tell you you could probably decode from this what frequencies were used, maybe. Are these exotic vacuum objects that are arranging themselves over the surface that it looked like on other areas where you could actually see the hexagonal structures and the larger ones? What is going on? Whatever's going on, it's not something you can do easily. Now, before I close out, I just want to say you are not going to want to miss another video on this channel. So I think right now is a time to tell your friends and family. It is time to start coming out of the closet, coming out of hiding. If you're into cold fusion, or you're into John Hutchinson, I think the evidence that I've shared over the last couple of weeks, which you can easily share, they're not long videos apart from this one, what is being revealed to you is hard facts of research that is being going on all over the world for the best part of 140 years. And without realizing it, people were observing aspects of the very same phenomenon. And so if you're interested about ways you can support this project, the first thing is like the video, go out there, share this video, talk to people, get them interested in it, and engage. Have a look at these, see what you can see. Can you decode the frequencies going on? Can you explain why this has silicon and calcium here but no iron, and why it has silicon and iron here but no calcium? Can you explain that? And then why it's mirrored and rotated over here? How can you explain that? And then there will be a description in the video of how you can support the project financially. And that's very important because we had some experiments to test with the Brown's gas generator, and also we have a lot of Hutchinson samples, and I would like to do a deep dive on these with isotopic analysis and so on, because what this is pointing to is the production of non-isotopic, naturally isotopic ratios being produced. And I can tell you already that with the testing of the coral sample in Russia, we did observe non-naturally occurring isotopic ratios, and quite wide non-naturally occurring isotopic ratios. So thank you very much for your time. This was Hutchinson effect, magneto-toro-electrogravitic field interference driven transmutation patterns on the MFMP fracture sample. I'll see you in the next video.